In Chapter 7, Section 7, we're going to do things a little bit backwards. We're going to go from the solutions to the equations. So we'll need this theorem. If you have a quadratic equation where our two solutions are r1 and r sub 2, then my equation is x squared minus r sub 1 plus r sub 2 times x plus r sub 1 times r sub 2 equals 0. Or we might have to take that entire equation and multiply it by some number. So it would be a times the quantity of x squared minus r sub 1 plus r sub 2 times x plus r sub 1 times r sub 2 equals 0. Another way to think of it is that some number a times x squared minus the sum of my answers times x plus the product of my answers equals 0. That might be easier for us to think of. And so if we know in this example that here are two answers to my equation, two solutions, 2 plus I over 3, 2 minus I over 3, first thing we should do is find their sum by adding them. When we add them, they have the same denominator, which is convenient, so we keep that. Add or subtract the numerators. 2 plus 2 is 4. I plus negative I drops out to 0, so we get cross-eyed there, and 4/3 is the sum of my roots. Let's find the product of my roots. Multiply the denominators. 3 times 3 is 9. Numerators, handy enough, happen to be conjugates, so we multiply the firsts, 2 times 2, which is 4, and the lasts, I times negative I, to get minus I squared. Don't forget I squared is negative 1, so 4 minus negative 1 is the same as 4 plus 1, and that's 5. So 5/9 is the product of my roots, 4/3 is the sum of my roots. The theorem says I can take my equation, which is x squared, minus the sum of my roots times x, plus the product of my roots equals 0. And that would be my equation except for one little thing. We don't like to leave all these fractions in our equation in standard form, so we'll multiply everything by 9, which is the common denominator, and that will eliminate the fractions. So multiplying everything by 9 will give me 9x squared. 4/3 times 9. The 3 and 9 cross reduce to 3 times 4, which is minus 12x. And then when I multiply 9 times 5/9, the 9's reduce and give me 5. So my equation in simplest form is 9x squared plus 12x plus 5 equals 0. Very handy indeed, and all we had to do was to add our solutions together, multiply our solutions together, put them in the formula, and eliminate the fractions. Alright, well here's another theorem. If r sub 1 and r sub 2 are roots of any quadratic equation, ax squared plus bx plus c equals 0, then the sum of my roots should be the same thing as the opposite of b, which is the coefficient of x, divided by a, which is the coefficient of x squared. And the product of my roots should be the constant, whatever its sign is, divided by a, the coefficient of my x squared term. So let's put that into practice to check my answers, and not only will that be a quick way to check our answers solving quadratic equations to see if they're correct, should you ever encounter a multiple choice test in the future, it might be a quick way to find the answers as well. So let's go back to early in the chapter. Start with a quadratic equation, put it in the quadratic formula. A is 2, b is 9, c is 5. Substitute those numbers in the quadratic formula, and we've been doing this a long time, so we'll simplify. 81 minus 40 is 41 for my discriminant. And we've got two roots. Negative 9 plus the square root of 41 over 4. And negative 9 minus the square root of 41 over 4. So since those are my two answers, let's add them together. Let's multiply them together, see what we get. So for adding my answers, denominator is the same. We're going to keep it. Negative 9 plus negative 9 is negative 18. And conveniently, the square root of 41 plus the square root of 41 drop out to 0. And negative 18 over 4 reduces to negative 9/2. And if we look, that is the opposite of b over a. Let's take a look. b is 9, so the opposite of that is negative 9 over a, which is 2. Now, we can't just assume that our answers are correct, because we also have to find the product and see if that is also equal to c over a. But it looks like we're on our way. Let's find the product. Denominators, 4 times 4 is 16. Numerators, well, fortunately, they're conjugates. So the firsts, negative 9 times negative 9 is 81. Last, positive times negative is negative. And the square root of 41 times itself is just 41. 81 minus 41 is 40. 40 over my denominator 16 reduces to 5 halves. And let's check that out. Should that be C over A? Well, C is 5. That's my numerator. A is 2. That's my denominator. So there's a quick way to check my answers. Take my two answers, add them together. I did get the opposite of B over A. Take my two answers, multiply them together. I did get C over A. So we can safely conclude that our answers are correct. All right, let's progress to this next example, which is not it's not the stumper, so to speak, but it's a tree killer. It takes a little bit of paper here. We're going to find a quadratic equation in the form f of x is ax squared plus bx plus c. In other words, a parabola. And here are the hints we know. The maximum is 8. Now, first of all, that tells us this parabola opens down because the maximum is 8. And it crosses the x-axis, that's what it means by when it says x-intercepts, at 3 and 7. The other thing that tells us, though, is where my graph crosses the x-axis, those are my zeros, roots, or solutions to my equation. So let's start by adding those numbers and multiplying those numbers. 3 plus 7 is 10. 3 times 7 is 21. So if I go back to the theorem we learned at the beginning of this lesson, my equation is something times x squared minus the sum of my solutions, which is 10 times x, plus the product of my solutions. If we knew what a was, we would be finished. Well, we know the maximum is 8. That's my next clue. And so that's going to help us because that's a y value of the vertex. And maybe looking at the graph will help us even more to fill out the rest of this information to see what a is, because we have in our graph a parabola that crosses the x-axis at 3 and at 7. We know that the y value of the vertex is 8, but we also know due to symmetry the x value would have to be halfway between here, or the average of 3 and 7. 3 plus 7 is 10, divided by 2 is 5, and sure enough, if we put it on the graph so we can visualize it, my vertex is at the point positive 5, positive 8. So again, we're averaging my two x-intercepts together to find out the x value of my vertex. So my vertex is 5, 8. And that's going to help a lot because we know x is 5 and y, or f of x in this case, is 8. So let's take my original equation here that we've worked at by adding my answers and multiplying my answers. Let's substitute in 5 for every x value and 8 for every y value, or the f of x value. If we simplify and solve for a, we'll have our equation. So 5 squared is 25. Negative 10 times 5 is negative 50. Simplify that. 25 minus 50 plus 21 is negative 4 times a, and that's equal to 8. Divide by negative 4, a equals negative 2. And if we can substitute that in for this equation, we'll be finished. So f of x is negative 2, that's what a is, times x squared minus 10x plus 21. Simplify that by distributing it out. It's a negative 2x squared negative times negative is positive, plus 20x. And negative 2 times positive 21 is minus 42. And there's my equation of a parabola in general form, given the hints that they've given me. And that's our look at Chapter 7, Section 7.